Okay, I'm going to make a video here going over the possible ways to do test G. Okay, this would not work very well for U sub because we'd get a 2x plus 4, which is not going to cancel that and be messy. It's not going to work well for trig sub because trig sub usually has something squared plus or minus something squared, either numerator or denominator and or with or without a square root. It's not, you're not going to find this as a formula one in the formula page. And integration by parts this is not one that we usually use for integration by parts. So it leaves it just partial fractions for this one. So if you did this problem, I'm hoping you did it in partial fractions. I'm hoping you factored that denominator, said there's an x in both of these. And that would leave an x squared plus 4. That doesn't factor, so this would have to go to the integral. That's a linear one, a over x plus, that would be a quadratic, so it's bx plus c over x squared plus 4. So to get a common denominator, this one would have to be multiplied by x squared plus 4, and this one by an x. Numerator and denominator, numerator and denominator, so they'd have the common denominator of that. But I need to figure out what, I don't really want to do that. I want to figure out what a, b, and c are. Looks like I'm getting x squareds. So I'm going to look at the x squareds, and I'm going to say there's none here equals a there, and b here, and no more. Then I'm going to look at the x's. And there's 1 here. There's no x's there. And there's a cx. But there's no, b is by x squared. So looks like c is 1. Look at the constants. And that's 2. And that's 4a. And x is times both of those, so there's no constants there. So this turns out to be fairly simple. It looks like a is 1/2. B, if a is 1/2, b must be negative 1/2. And we don't even need to do matrices. And c is 1. So we have the integral of 1/2, pulling the a out, of 1 over x dx, plus the integral negative 1/2 x plus 1 dx over x squared plus 4. So, integral of 1 over x is ln x, so we get 1/2 ln absolute value of x. This substitution is not going to work very well, not much here. So we could do a trig sub on that, but I'm just going to split this. Since the numerator's got addition, I can put this over the denominator and 1 over that. So I'm going to have minus 1/2 x over x squared plus 4. And then plus 1 integral of 1 over x squared plus 4. This one is, if I let u equal x squared plus 4, du would be 2x dx. dx would be du divided by 2x. So we have the 1/2 ln absolute value of x I'm going to put this in place of the dx. The x's would cancel. I get a 2 in the denominator, so I get minus 1/4. I let u be this. So this is du over 2x. The x's cancel, and this is u. So 1 over u's antiderivative is ln of u, but u is x squared plus 4 plus, and this looks like the arctangent rule. If I have, let's see if I can get it on here, x squared plus something squared under du, that turns into 1 over whatever the constant is, and it looks like that's a has to be 2 if I have 4 here. 2 squared is 4. So it's going to be 1 over 2 arctangent, and u, which is my x, over 2, and then plus c. So in the end, I use the table. So I could have let this one be that one, but I started off thinking I'm going to show partial fractions on this. And that's my solution. Now I'm going to do this one. Now this might be able to be done with by parts, but I think it's going to be pretty messy. I think I want to use tables on this. And I think I'm going to use the one that reduces the cosine. So that's, this one reduces the cosine. And then I'm going to use the one that reduces the sine so that I get it down to something where there's only, that would mean if I reduce the cosine by 2, it would go 3 to 1. And if I reduce the sine by 2, it would be sine to the squared down to sine to the 0, which is just 1. So I'm going to use 11 and 12. So I need to get this someplace. Let's see here. I'm going to make do with this. So using 11, which reduces the cosine, my m on this is going to be 2 and the n 3. M equals 2 and n equals 3. So I get sine to the m plus 1, sine cubed x, cosine to the n minus 1, cosine squared, 3 minus 1 is 2, x divided by 2 plus 3, 5, no minus, plus n minus 1, 2 over m plus n, 5, integral of sine, still 2, didn't change it, cosine n minus 2, which would be 1, okay. Now, I have this. Plus 2/5. And now I'm going to reduce the sine down by using the sine reduction, not the cosine reduction, but the sine reduction one. So now my m is 2 and n is 1. So m is 2, n is 1. So I'm writing those down so I don't forget it. So I get negative sine to the 1 less than m, so that'd be sine to the 1, so I don't even need to put that in, the 1 in sine x, and cosine would be squared over m plus n, which would be 3, plus m minus 1, so that's 1, over m plus n, 3, integral of sine to 2 less, it was 2, down to 0, so that's sine to the 0 power, or 1, so I don't need to put it there, cosine to the n, which is 1, so I don't need to put the 1 there. And now I have this. Minus 2/5 times this, so minus 2/15 of sine x cosine squared x. And then I'm going to have plus 2/15. And the antiderivative of cosine is sine x plus c. Now, I chose to do the cosine reduction formula first and then the sine. You could do them in the other order, and it would look a little bit different, but it should end up being the same answer. Okay, that's 2. 3. Now 3, this would be easy with substitution because I get an 8x under my du and the x's would cancel and I have an 8th outside and I could do it. But I didn't ask you to do substitution. This one could also be done with trig sub. I can't do it by partial fraction because this doesn't factor. And parts doesn't work on it, so, and there might be something in the tables on this, but I don't think there is, so trig sub, if I were to do this one, would be trig sub, and some of you may have done that. This is plus, so on my triangle, I need to put one of these, the square root of the 4x squared, so that'd be 2x on one side and square root of 9, 3 on the other, and then when I go a squared plus b squared equals c squared, I get 4x squared plus 9, that's c squared, so I have to take the root. And so I get not exactly this, but I get the square root of this. Anyway, step 1, as I talked about in class, get an expression for x. Now, I put it here, so my expression for x is going to be 2x over 3. If I put the 2x over here and 3 here, it'd be 2x over 3. That would be tangent, but the way I got it, it's cotangent of theta is adjacent over 3. So I'd multiply both sides by 3/2, so I get 3/2 cotangent theta equals x. Step 2, got to get dx, so I'm going to take the derivative of this. So it's 3/2, the derivative of cotangent is negative cosecant squared theta d theta, and the derivative of x is 1 dx. And if you didn't remember the derivative of cotangent, it's right there on this formula page. And step 3, we want an expression for this, so that we have something for that. So I'm going to use this with the 3, so that's hypotenuse over opposite, which is the reciprocal of sine. So the reciprocal of sine is cosecant of theta is hypotenuse, square root of 4x squared plus 9 over opposite. If I wanted to get this, I would multiply by 3. And then I would square that. So I'm going to go right to this now. And what is x? X is 3 halves cotangent theta. So I've replaced the x. Now I got to replace that. Well, the square root of that is this, so I got to square this. So that's 9 cosecant squared theta is this. Then I got to replace the dx, and that's right here. So that's minus 3 halves cosecant squared theta d theta. The cosecant squareds cancel, and I get negative 9 fourths over 9. So negative 9 fourths divided by 9 is like that. And so the 9's cancel, so I get negative 1/4 antiderivative. Cosecant squareds canceled. I got the constants out, so it's just cotangent theta d theta. The antiderivative of cotangent is ln cosecant, negative ln cosecant x, but it's theta, so negative 1/4 negative, so that turns that to plus, ln as a value cosecant theta. It says x in the formula, but the variable is theta here, so it's cot theta plus c. So to finish this, it's 1/4 ln and cosecant from the triangle. Cosecant's the reciprocal of the sine. Cosecant is this over that, this over that. So it's square root of 4x squared plus 9 over 3. Okay, this one looks like an integration by parts, because if we do the table and let u, since we know when we take the derivative it reduces an x squared to 2x dx, I'm going to let that be my u, and this be my dv, the derivative of v, so that's cosine x dx. Antiderivative cosine is sine. So this becomes u times v minus, these were these two, so I got to use these two in the integral. So that's 2x sine x dx. Now, I still have an x, but it's not as messy as it was. That suggests I should do it again. So I have x squared plus sine x minus, I'm going to pull the 2 out, of x sine x dx. To do this part, I'm going to let u be the x, so that when I take the derivative, it gets less. if I'm letting x be the u, then the rest of this goes here, the derivative of v. So the antiderivative is negative. No, derivative cosine is negative sine. Yes, so negative cosine x. So this becomes x squared sine x minus 2 parenthesis uv, so that's minus x cosine x, these two multiplied, minus the integral of these two. So that's the integral of minus cosine x dx. And the minus of minus is plus. And so I get x squared sine x minus 2 times that is plus 2x cosine x, and minus 2 antiderivative of cosine is sine. That was the integration by parts. Had to do it twice to get it. Next page. This one, parts is not going to work. Partial fractions, this factors, but with the square root, not the way we do partial fractions. There might be something in the tables, but I doubt it with the cube, so we're to trig sub. So, trig sub, this is minus, and this is the positive, this is the negative, so I got to put 1 on the hypotenuse and x on one of the legs, the square root of x squared. So I'm going to put x there. So this side be 1 minus x squared. So step 1, x over 1, or x, is sine theta. Step 2, we need a dx, so we take the derivative, and dx equals cosine theta d theta. And step 3, we need an expression for that. Adjacent over hypotenuse is the cosine, so the square root of 1 minus x squared is the cosine of the angle. So now I'm going to replace all the pieces. I have the integral. 1 is fine to keep. The square root thing is cosine theta cubed. And we've replaced that. We've replaced this. We've got to replace the dx, which is cosine theta d theta. One of the cosines cancel, so I've got the integral of 1 over cosine squared theta d theta. And you might be able to use a formula in the table like the cosine reduction formula. You might use, say, this one, but we don't really want to reduce it because it's already minus 2. So that's not a good plan. But cosine in the denominator is like a secant in the numerator. So this would be secant squared d theta. And then, fortunately, I recognize that secant squared is the derivative of tangent. So the antiderivative of secant squared is tangent theta. But this is theta. I got to go back to my x's. And so my x's, the tangent, is x over square root of 1 minus x squared based on my triangle. And I'm done. So now we're going to go to this one. There's no derivatives to cancel the integral, so I'm going to have to actually integrate this. The antiderivative of 4t is 4t squared over 2. Antiderivative of negative t to the fifth is negative t to the sixth over 6. Evaluated from 4 to x. So I'm going to put x in for there, and I'm going to get the 4 over 2 reduces to 2x squared minus x to the sixth over 6, or 1/6 x to the sixth, minus, now you got to put the 4 in, so it's 2 times 4 squared. 4 squared is 16 times 2 is 32. 4 to the fourth. 4 times 4 is 16 times 4 is 64 times 4 is 256, I believe. Minus 256 over 6. And this would be a of x without the integral. And there's some simplifying you could do, but not worried about it. Let's see. I got to check. 4 times 4 is 16 times 4 is 64 times 4 is 4 to the 6th. I don't think it's 256. 4, 4, 4, 4, 4, 4. That's 16 times 16 times 16. That's more than 256. Okay. Need to pull out a calculator and get this figured out. 4 to the 6th. 40. Much bigger than what I had. And 2 would go in both of these and reduce. But anyway, that's a better answer than what I had. Okay. To the final page. Since we're taking the derivative first, we'll get whatever the derivative of this is. I don't want to do that. And then we're going to integrate it, so it's going to take it back to this, and we're going to put in the x for every place the t was, so it's going to be the square root of x e to the x minus, then we're going to put in the 3 into the antiderivative of the derivative, which is just this. So I'm going to get the square root of 3 e to the 3. Done. And I hit my camera. Okay, now this one. Now I'm going to integrate this, which is going to be the capital function of this, with x put in, minus the capital function with the 3 put in. And then I got to take the derivative with respect to x. So that's going to wipe this out. So it's going to be back to this function, the derivative, capital F, with x put in it. So it's just going to be a square root of x e to the x. And that's all there is to that problem. All right. We're supposed to, this is the derivative. This is the antiderivative. And at minus 4, it's supposed to be at 4, 8, 12, 16. And at minus 4, it's here. So there's positive area from here to there. That's 2, 4, 5 by 2 is an area of 10 and a half, 5, plus 5. So my graph here has to go up 5. 4, 4, 4, 4. 5 would take me to there. And it's going to a slope of 0 from a positive slope going to 0. And then for 3 units, 1, 2, 3 by 1 is 3, so that's negative 1.5. By 4, it comes down, oh, excuse me, it peaks there. It comes down 1.5. So I was at 8, 12, 14, 16, 17, 18, no, 16, 22. Did I go up? How much did I go up? 5. 21. Now I got to come down 1.5 by 4. So it's someplace like this. And then it's going down. See, these are 1 by 2. So that's 2, 2, 2, negative, 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 negative. So I got to go by 2's. So if I go over 2, I should come down 4. Go over 2 more, I should come down 4. 4, 4, 4. Now before that, this area, see that's 12 to negative 4, that's 8. And this is 1, 2, 3, 4, 5. 5, and this side is 2. The average of 5 and 2 is 3.5. 3.5 by, what did I say, 8? So 8 times 3 is 24.5. It's 4 more, so 28. So the area here is 28, and it's going fast here, so, and going down to closer and closer to 0. But this is positive area, so it's going up 28. So at minus 12, I have to be 28 lower than this. I'm at, let's see, I was at 16. 28 below 16 is 12 below 0, so that's minus 8. 4, 8, 12. Minus 12, I should be right there. And it should be curved and steepest on this end because it's the highest positive velocity, so it's going up the fastest and slowing down. And then it goes to a slope of 0. What's the area here? That's 8. This is 5. 40 in half is 20. So now I got to go down 20 more. 4, 8, 12, 16, 20 by negative 20, slope 0. So that's what it should look like. And I'm done.